All right, hello and welcome back. My name is Corey, and this is the series where we are building a programming language from scratch. That's meaning if we don't write it, it doesn't exist in the language. And so far, we're on what was this number 18, I think, episode 18. What have we done? We've got memory pool stuff. We've got a garbage collected object. We've got integers, we've got floats, we've got all of our mathematical operators, addition, subtraction, multiplication, division, modulo. We've got parentheses, we've got errors. Um, we've got typecasting. That's right, we added that last time. So what are we doing next? Well, we want to have booleans. And it takes a little longer now to add new types because we have to make sure that it plays nicely with the other types. So for example, today by adding booleans, we're also going to need to add the casting as a boolean. And so what happens if we cast from an integer to a boolean or a boolean to a float or something like that? Yeah, we get to make those decisions. And well, like I said, if we don't write it, it doesn't exist. And Booleans are definitely a part of any language, true and false values. So one thing that I did a massive rewrite. Do I have this here? I should. Let's see. I said a massive rewrite. I didn't rewrite stuff. I moved things around and I added missing documentation. So I'm still thinking that we need to call this, with the version number or the episode number. But if we look at the files, all of these are now populated for the source and CPP. Oh, am I missing one? I thought I got them all, but I may be missing it. Yeah, because we have 3 tests and I've only got 2 listed there. I think the garbage collected test isn't listed there. But also in the class list, there was a missing description. And then the other thing I did was I broke out the constructors of the AST nodes. They were all in the .h file because they were empty. They were just using an initialization list. But again, just for consistency, I broke all of them out into the where they should have been. Yeah, does that make sense? um, yeah, that's where I put them. Anyway, so I didn't show that on camera because, quite frankly, it's tedious work and it probably took me about an hour to do. And you don't want to watch just an hour of that when you can watch an hour of me rambling on like this. So, having said that, let's just jump in. And what we want to do is we're going to start and we're going to make Boolean expressions. Now, I think you've seen by now plenty of times, what I'm trying to say is you know by now that there's a lot of different parts of the project that we have to touch in order to add these core functionalities. And it's just which direction do we want to start on? Do you want to do the flex and bison part first and then kind of work our way back and say, and it continues? Oh yeah, that's the other thing. In the make, I've said for the last, I don't know how many, 5 episodes or whatever, that I didn't like calling it watch-test, and so I have renamed that to test-watch. Okay, that was a simple change. But anyway, okay. So back to this. Yeah, where do we start? And I think I kind of like starting with the make file. So caps lock was on evidently. If we start with the make file, we know that we're going to have some objects here. We know that we're going to have let's see, node add, and this an AST node for a Boolean. Now this is for a literal, just like the integer literal and the float literal. This is a new type. It's going to be there we go. And Boolean. And just like I did with integer and float, I'm spelling it out, even though in our program we may cast as bool. Okay, and then we're also going to need a computed expression that is of type Boolean. And I'm getting there. This list is getting long. Maybe there's a better way to organize it. I'm not sure. But computed expression Boolean. All right, now we need to make these two rules. And that is going to be, so here we are, AST node. Let's copy the add one, and we'll just, because now we're on 56. So 56 and 57, substitute add for Boolean, do it a couple times, there we go. And now we need to go down to the computed expressions. There we are, computed expression. We'll steal the integer one. There we go, and this is going to be similar, but it's line 111 to 112, and we're going to substitute integer for Boolean. Okay. These don't exist yet, right? So we've got at least 4 files that we know that we need to make. Our AST node, Boolean, and our computed expression. All right, so let's do that. In source, we know I'm going to copy the AST node integer into the AST node boolean.cpp, and I'm going to copy the computed expression integer into the computed expression boolean. Okay, I can go to the includes now and do the same thing. I'm going to copy the AST node integer to AST node boolean.hpp and copy the computed expression integer into the computed expression boolean.hpp. I think that's right. I also know that I'm going to have another cast. I've got an AST cast float, AST cast integer, and I'm going to have an AST cast boolean. There's not a lot more of these casts that are coming along. Like I said, maybe a string later. Makes sense, cast an integer as a string or something like that. But, okay, so we need to copy the AST node integer. Nope, I didn't mean AST node. AST node cast integer to an AST node cast boolean. And I'm going to need to do the same thing in the source. Copy the AST node cast integer to the AST node cast boolean. Now again, these are just getting everything in the right place, and of course I need to make a makefile entry for the AST node cast integer or AST node cast boolean. AST node cast, well, it doesn't matter which one I grab. I can do this one. Boolean, and search for cast. There we go. This is 96 and 97 change float into Boolean. That's fine. Okay. So now there's 6 files that we need to edit, right? There's the, we've told our makefile that there's going to be 6 files. There's 3 of these objects, and so they have their source in their .cpp. And let's just jump in. You know me, I like saying what it should be first. So let's do the include AST node Boolean source AST node Boolean. The include for the AST node cast Boolean. And then the source for the AST node cast Boolean. And then finally the include for the computed expression Boolean and the source of the computed expression Boolean. Okay. As you see, we've got 6 buffers there, 6 files open. All right, so for this one, we need to change all the integers into Booleans. So %s, we'll do the all caps one to Boolean G. There we go. And if I just go to 3, oh wait, right. There we go, right, and 5. Okay, now go back to 1, because now we're going to do integer Boolean G. And this is just, you know, trying to automate as much of this as possible. Now let's go back to B1 and see. So that's why I went ahead and made these. I went ahead and filled these in because I knew that we were going to be copying them, and why not do it before we get here? So, all right. That represents a Boolean literal. Booleans are, nope, I can get rid of that. The parameter is val the Boolean to represent. Oh yeah, another thing is I renamed all of these. They were just loc, L-O-C, and that looks stupid. So I changed it to location. Anyway. Bool val and the Boolean, and there we go. Now let's do buffer 2, make it match this. So I can go back and do the same integer to Boolean. And I can probably do the same on buffer. That's 2, so buffer 4. And did I write that? And now buffer 6. Not all of those should have changed, but for right now, that's fine. I'll be coming back to them. Okay, so for the that should have been nope. I will need that, I'm pretty sure. Oh wait, I'm on the computed expression Boolean. Oh well, that's fine. Let me go back to 1, which is AST node Boolean. That's where I was working on. Don't get sidetracked, Corey. And now B2 is the AST node Boolean. Yeah. So done that, included that AST node. So we're going to need to, there we go, a Boolean but I think the easiest way to do this is to say this val, and obviously if it's true, do a 1, else do a 0. Yeah. All right, let's go back to this. This should be a bool called val, and there we go. I did call that val, didn't I? Yeah, it's val. We're going to dump it, and I'm not going to use the toString, but we will say true or false. That should compile. And now for the compile thing, we need the opcode of Boolean, which we haven't created yet, but we know that we're going to need to. In fact, include opcode, just like integer float, we're going to add it here. We're going to say Boolean. There, that's gone. And then for make a copy, return a new AST node Boolean with this value. Sure, that seems good. No problems there. Seriously, seems pretty good. Let's go to buffer 3, which this is our AST node cast Boolean. And to a Boolean, the expression to be typecast, the location, and then we've also got what do I do with the dump, a compile, or an AST node. I mean, yeah, the make a copy. And we've got the expression being typecast. That's all fine. Okay. Buffer 4. We know we're going to need another opcode at least. So let's Boolean there. And I'm going to open up the opcode one again. I should have remembered that I would need this, but oh well. That's under include opcode. And we've got a cast integer, cast float. And let's cast Boolean. Typecast to Boolean and then push. All right, now we're back. So for the compile, yep, we need to compile the whatever the expression is, and then we say now cast that to a Boolean. To make a copy, we've got to make a copy of the expression. And the dump seems correct. Okay. Making good time here. We've got 4 of the 6 files done. Let's go to B5, which is our computed expression, Boolean. And that's correct. The Boolean value. Okay. And computed expression Boolean. And now this has a lot of parts, right? But we've got an is equal. Something tells me we're about to have to add an is equal Boolean. And we'll do that in a moment. Okay? We'll do that later. So far, add, subtract, multiply, divide, modulo, negative, integer, float. And we're not doing the typecasting yet. We'll do that later. I just want to get it compiling and working as just a standard Boolean. And then lastly, we've got this. This is not an integer value. This is a Boolean value. And does that still need to be a friend class? Probably so. And that means I'm probably going to have to add integer. And these are so that they can inspect inside one another. Is that right? Yes. Okay. B6, and now our constructor is not an int64. It is a bool. For the dump, it's easier to say true or false. To make a copy, that's fine. The is equal. I don't think I like comparing these to integers or floats, doubles. It made sense for integers and floats, but I don't think, well, maybe it does. Should I? You know what? I'm going to leave it just for the moment. Well, no. I don't think I'm going to leave it. I've removed it, and now that means I need to go back to the previous and remove the is equal here. How do I add? I can't add. How do I subtract? I can't. How do I multiply? Can't. How do I divide? Can't. How do I modulo? I can't. Now there's negative, but that's not the same as the not operator. So I'm going to do away with that. And now what do I do? If I want to convert it to an integer, I'm going to say it's a 1, and if it's false, it's a 0. All right. And now let's go back to the previous one and remove the add, subtract, multiply, divide, modulo, and negative. So, okay. Now, if I go over here, it's saying that we've got the... Why did it not do... Oh, because it stopped, because I've got a problem somewhere. That's fine. I think I can exit these and edit my make file and AST node cast float. So AST node cast float and AST node. So we've got cast boolean, cast float, cast integer. That's fine. And now cast boolean, cast float, cast integer. And what's it complaining about? No rule to make the target AST node cast float.o. Isn't that what this one is right here? Cast float .o. Unless you're seeing something that I'm not. I mean, it is right after the cast boolean, but they're separated by a line, and there's nothing there. Yeah, there's nothing there. It compiled the AST node cast boolean just fine. AST node cast float. .o. That doesn't make any sense to me. Oh, right there. $2. That happens. All right, what is it not like? We can just go back to all of these. And it wants me in the computed expression Boolean. That was control B5 or whatever. That's right. I need this to be a bool. And oh, it's saying it doesn't like its narrowing from int. This is a template, which means so in compiling computed expression Boolean. No, wait, we did that, didn't we? Oh, it's in making a computed expression Boolean, and I think I know where this is. So if we go to our computed expression Boolean, the problem is these right here. I'm supposed to be making computed expression integer and float. That got caught up in the mass replace. Evidently, I still have to say double. I've got to wrap it in. There we go. Or I guess I could have put 1 point. In fact, now I want to know if I could do that. One point. Yeah, that would work. Okay, so we've got all of our tests passing. Now, I already know that we're going to need a typecast. Wait, no, wait. Didn't we just do that? Yeah, we've created these files, the ASC node Boolean, cast Boolean, and computed expression Boolean. We can't use them yet, though, because we haven't told the program how to execute them, and we haven't told Bison or Flex how to recognize them, and we haven't written any tests that include them. Okay, so let's just jump in. So we've added the opcodes, and so let's edit the source program. Let's do the dump bytecode and then the source program execute. So we're in the dump bytecode, and we're going to have float. Yeah. And instead of a float, we're going to change this to Boolean. And we do need to make sure that there's 1 after that. And this is Boolean, and then true or false. That's fine. It is definitely going to be a 2-byte thing, whatever it is. And we're just going to go down, cast integer, cast float, and then cast Boolean. Ah. My brain has a hard time sorting out when I hit the I for insert versus the caps lock versus the escape versus whatever. What is it not like about that? Boolean followed by, in parentheses, a ternary expression. I don't think that's going to fix it, but... Oh, because it did read it, Corey. It says the comma. Oh, it should be a colon. A lot of people don't like ternaries. I really like them for some reason. They're just very elegant to me. Anyway, okay. Buffer 2. We've got the same thing here. 5. And here is going to be a Boolean. Push back garbage collected. Boolean. And I don't need to do this. I just need to say this. That's simple enough. Okay. No, I'm not going to write it yet because... Yeah. Cast float. Now we've got this that we're going to do. Cast Boolean. And here's where, yeah, operand. Caps lock again. Boolean. It's going to complain at that because it's going to say, I don't know what you want. Computed expression Boolean was not declared. Of course it wasn't. Computed expression integer float and Boolean. That'll solve part of it, but now it's going to say oh, I need okay. Has no member named Boolean. We've got to add that. So first we're going to do our include of computed expression and our source computed expression.hpp. And then we're just going to go through the litany. We're going to say computed expression integer, source computed expression integer, include computed expression float, source computed expression float. And, you know, we need it for the Boolean as well. So include computed expression Boolean, source computed expression Boolean. Okay, there we go. We've got 8 different things. So what we need, we've got our for our is equals, we've got one is equal this one. We need this to be a bool. Okay, so is equal we've got to create, and we also need to create the dunder bool. All right, I'm going to do that. It's going to complain. So that's okay. We're not going to stick around for the complaints. We're just going to go on to the next file. We've got our this here. So our is equal for a bool. Okay. And now our float, except this is now no longer float. It's going to be a Boolean. Don't know how to convert this value to a Boolean. Okay. Now we've got defaults for everything. Did I call it bool in the other? Corey, you need to be consistent. I know. B1, and that is going to be Boolean. And go ahead, tell me where I made the other mistake, because I'm going to need to segmentation fault. Again, because probably need to clean it. And that means I've got a dependency somewhere that is not captured in the make file. And yeah, I'm not sure what a good solution for that is. Yeah, they're good. Okay, so we know that our casting is not going to work and our testing against it. So let's write some tests and prove that. Okay, so this is easy enough. We can, I don't want to lose all of these files because we're going to need them. But yeah, here's our test. And going to the bottom, the typecast. Are they all expressions? Should I? I'm just thinking out loud. Okay, let's do this. We'll just do a couple of test expression Boolean. We're going to say auto p1 is equal to tingbase.compile script and true. And then expect EQ p1 dot execute dot result comma true. Sure, that should work, and we should be able to do the same thing with a false and get a false. Now I'll tell you what I'm expecting to happen. I'm expecting the first one to fail and the second one not to fail. Why? Because it always defaults to false. Oh no, they should both fail. They should both fail. Sorry. Oh, stack is empty. Why is the stack empty? Oh, because we haven't written the flex and the bison stuff. Okay. I was forgetting something. Let's start off with bison. And these are going to be tokens. And we've got our... Where's the integer? And there we go. Let's do this as a percent token bool, and we'll just say boolean and boolean. There we go. Doesn't need anything else there. We're going to need to include our AST node float and integer. We're going to add Boolean and our casts as well. And it's not going to be done yet, so that's fine. So if we say, oh, we need an integer thing, so let's go back up and token cast Boolean, and we'll just call that Boolean. And that means this up here cannot be called Boolean. It needs to be called a Boolean literal. Yeah. And now there we go. Well, this will be a node cast Boolean. That's fine. And then the other thing is up here. We've got an integer, we've got a float, and a Boolean. There we go. And I'm going to point out that the $1 is a Boolean value because we told it up there in the token that Boolean, its type is a Boolean, just like a float's type is a double and an integer's type is, what is that, a uint64t or an int64t. Okay, we can do that, and now we need to go into flex and tell it what a Boolean is. or how to send across a Boolean. So flex, and to do this, we just go down to the bottom, and I might put our reserved words up at the top. So for example, true. By the way, you can, this could be your language, right? That if you're following along, you could say, no, true must be all caps. It has to be capitalized T. Or maybe you want to be able to recognize any capitalization of TRUE, whatever. You can do that. For me, I'm going to say return tang parser make Boolean, and it is going to be true location based on the current location. Alrighty, and now false. See what this looks like. Okay. So it's no longer giving us the error of the stack not being right. And our P1 get result is true. And this is true, but we haven't wired up that we haven't written the the code to tell it how to know that those two are equal. Why? Because the top true is a there we go. This one is a garbage collected value that contains true, and this is just a Boolean value that is true. So let's wire that up. Now, what's my list of files here? So I need to go into, we're going to start off with the computed expression.hpp, sure. And we'll see this is equal with a Boolean. That's what we want. But we need to do this in the computed expression Boolean HPP. So buffer 7. And there we go. We just need to add an override. And now it's going to complain because it's not declared, but that's fine. Now buffer 8, we can write our we don't need that. Boolean computed expression Boolean is equal const override. That's all correct. And now what goes in there? It needs to be a return, and this is true or false. Is it equal with the bool? This val is equal to val. That should work. Oh, we don't need the override word out here. Let's hope. Maybe. Oh, it's not liking that. Why? I'm probably missing something. Computed expression Boolean is equal. Am I missing something in the garbage collector? Maybe. Let's do our source. Garbage. No, I want to do the include. Garbage collected. I mean, these are the protected things. Oh, here we go. With the supplied value. And we need to do that with the bool. Or the, with the, yeah. All right, and now it's going to complain about it missing. That's fine. Edit the source for garbage collected. And yep, it's saying it's missing. Cool. All of our tests pass. And I'm not too worried about that, about making them fail first. Well, they were failing, and I wrote the stuff that made them pass. Okay, so let's go back to our tests. Do I already have that in here? Do I have my tests? That's 9. Okay, buffer 9. And we've got our Booleans, and we're going to... For the typecasting, so 8, no, there we go. R9. Why am I doing it this way? Just it's easier to do it batch wise in my head. Nope, didn't mean to do that. I meant to do that. P10 and then P11. And now what am I going to do here? I should have said a 0 as... Did I just say bool? Did we tell it how to recognize this? We're going to use shorter stuff for the inside of the, I mean, customer facing, right? So 0 as bool versus 1 as bool. And I don't think, and now, yeah, let's do a 1 point as bool versus a, oh no, that should have been a 0 point as bool versus a 1 point. Okay, so what should this be? 0 as bool should be false. 1 as bool should be true. A floating point 0 as bool should be false. Floating point 1 as bool should be true. And then a 0.5 as int as bool should be false, right? Why am I doing it like that? Because this is going to be a 1.5 as an int as a bool should be true. And this is just to say, you know, checking the how do the typecasts line up. 12 there, this should be a 13, and this should be a 13. Well, let's see what happens. Stack is empty, stack is empty. Why? Because all of those use the words BOOL, and we have not written what that is. So let's go back to flex. That's buffer 11. And we'll go down. The int and float, I'm going to move them up to the top. There. Int, float, bool, and this will be a cast Boolean. Flex didn't give me any errors. Oh, of course. We don't know how to cast it. We have to write that. Remember, none of this exists unless we write it. So, yeah, it doesn't know how to cast it. And what is that? That's going to be called, so just starting off with the computed expression. We've got our is equals and the dunder Boolean. And now, do we have the computed expression integer? Yes, we do. 3. That's what we need. And at the end, override. And we need this for the float as well. So that should be 5. Wait. B5. Okay, now it's going to complain that those don't exist. I know they don't exist. So let's do this. Let's do B4. This is for the integer. Boolean, and we should be able to do just that. Let's just see if it's going to complain about not knowing the type. Because we didn't include it, and yeah, it doesn't like it that it's narrowing unless we well, I didn't read it all. I probably should read it all. But if I just say a bool, in other words, I'm telling the compiler, yes, I know that I'm doing this. Trust me, it's okay. All right. Let's go to, which one am I on? I'm on 4. I need to go to 6. So buffer 6. Down at the bottom, paste. Garbage collected, computed expression. OA float, and now up at the top I need to pound include the computed expression Boolean. Okay. Oh, all of our tests are passing. That's a good thing. The one thing I want to check on is it's been in the back of my mind. In our computer expression Boolean, B7, we've had these two classes listed as friends, and if we do away with that, is everything still going to compile? And I think the answer is going to be yes. Yeah. I want to check a few things. I think it was buffer 11 that was nope. Our test, buffer 9. And I want to see P12 P12 dot dump bytecode. Just give it a little bit of space. There we go. Cast integer is happening first, and then cast Boolean. And that's not something you can optimize out. Well, other than since this is a literal, you could, say, well, I'm going to apply that. Basically, you're executing that little bit of code. Okay, sorry. I was thinking, not out loud. Now, the other thing we probably need to be able to do is, well, I was going to say, should we be able to cast a Boolean to an integer or a Boolean to a float? We could write it. It wouldn't be the end of the world. If we were, this would be like, whoops, 14, 14, and then this would be a true as an integer. Let's just do this. Why? Because we can now, there, 14, and this will be 15, 16, 17. We're going to go back up. We've got 14, 15, 16, 17, and this will be a 0 as, not a 0, a true as int, false as int, true as float, and false as float. Sounds like a really bad poem. And true as an int, we'll say it's going to have a value of 1. False as an int is 0. True as a float, 1 dot. And false as a float, 0 dot. All these should, well, fail. Oh, and I'm still... I didn't mean to do that. I meant to do... Oh, did I already write this? Where would that be? That would be in the computed expression Boolean. So buffer 8. Yeah, I did. I told it how to convert to an integer into a float. Oh, I'd forgotten that I did that. It's been a long day. Long night, actually. All right. So we have Booleans. You say, why don't we have ands and ors yet? Because that requires branching. Because we have to do short circuit evaluation. What does that mean? Well, to say an or... You know what? We do need to add one more. And that is we need to add a Boolean. And so that is going to be this val. Don't need to do anything to it because it's already a Boolean. And it's going to say, hey, I don't know. It's not part of the class. I know that. But we need to go to our HPP. So that's buffer 7. And just like we have that, we're adding a Boolean. So we should be able to convert back to ourself. And now we need to add that to our test, which is at number 9. Yes. So yank those last ones. So 16, 17. This will be 18. And 18. Oh, 18 and 19. Corey can't count. 18, 19. And this will be as bool. And this will be bool. And we should get a true and false. And that should pass. It does. Say, do you want it to fail? Sure, just change this to true and you'll see, yeah, this one failed. Yeah, it failed. So, okay. So we've got all these tests for our type conversions, and maybe they should be broken out into the different ones, converting to a float. But anyway. But the composed ones are a little harder to break up, you know, int as bool. Yeah, okay. Oh, so what I was saying about ands and ors, that will require short circuit evaluation, and we will talk about that more when we get there, but in order to do that, we need branching in our system. And yeah, we'll have to talk about it. Okay, so let's start wrapping all of this up. Get status. Just want to make sure that I don't have anything that looks totally weird. That's the stuff in flex. Everything's looking correct here. Sure. All right. We're going to do things in include, source, and the only thing I'm missing is, yeah, that's fine. Git commit dash am, and we are, add Boolean true and false. Say again, Corey. Seems like a lot of work. And I would say, of course it is. But that's true for anything where if you don't write it, it doesn't exist. So, and we're laying the groundwork, the foundation parts of this. So let's see. Now what do we need to do? We need to make our docs-pdf. And in so doing, bringing this over, this is what it used to be. There should be now, after I refresh it, an AST node Boolean and cast Boolean. So, yep, there we go. And everything has documentation as to what it is. And I'm glad I thought of that, saying it. So, vim test, and which one are we missing down here? Garbage collected. And we're going to say file, and this is going to be test the generic behavior of the Tang garbage collected class. And once again, there, we've got it. And yeah. Update docs for episode. You know me, I never remember. So what episode are we on? Episode 18. All right. For episode 18. And get tag-a episode.018. At this point, we're on episode 18 and we're only just now, well, we've got floats, integers, and booleans. And it's been 18 episodes, and I think you can see it's really taking this much work. I don't know, maybe you don't like watching me program or something, I don't know. But this is what it really takes to write this kind of stuff, right? And you say, maybe it would be faster if you were using an IDE. I don't know, maybe. But also, this is more fun for me. So git push origin episode 18. And it is there. The last thing we can do is check our count lines of code, and, well, we've got about 2 to 1 code to comments, so I guess that's fine. We probably need more comments, at least more descriptive stuff for just how Tang works. But for now, here we are, and we look at the tags. There's our episode 18, so it's there. And as always, I hey, hope that this has been somewhat interesting for you. And it's fun for me. I enjoy making this. I enjoy the programming aspect of it, but I like the fact of making just a language and getting to know the to know that we understand every single part of it. And it's getting bigger, right? It's getting to the point that it's harder to hold everything in my head. It's like, wait, what file was that in? Um, so that's why I have it doing the documentation, and that's also why we have the unit tests, because trust me, later we will get to some things that I'll make one mistake and it will completely break stuff. So um, yeah, thank you for following along. Have a great day.